Well, hi there. This is lesson 14. And lesson 14 is fairly long, so if you were planning to do a short set of notes on this, I would plan differently because there are two major things that we talk about during lesson 14. And one of them is parts of a whole, which is a fairly easy concept, but the other part is probability, and it does take a little longer to talk about. So I want to assure you that we'll cover it all, but it will take a little bit of time. First of all, parts of a whole are problems about parts of a whole with an addition thought type pattern. A part plus another part equals a whole. And that's, if you have a half a glass and then you add another half a glass, you end up with a full glass. So that's basically what that's about. You're talking about that. Some parts might be expressed as fractions or percents, and you'll see that just a little bit later on in the video because I actually have a couple drawings that I want to show you. Now, the other part of lesson 14 has to do with probability. And we've probably done some things with probability over the, probably last year, I'm sure. And there are some vocabulary words that go with it. Probability is the likelihood that a particular event will occur. Okay? And we figure probability, we either write it as a fraction or we write it with a decimal, or not a decimal, but a colon, or we actually write it as a percent. Now, a note. These are important, and I want these in your notes. Probability of 0 means that an event cannot occur. Example, the probability of rolling a 7 on a 6-sided cube with the numbers 1 through 6, that's 0. Why is that 0? Because there is no 7 on a 6-sided cube with the numbers 1 through 6. So it would actually be, you would write it as probability, you would write it 0 out of 6 because there's no 7. There's no 7 on a 6-sided dice. Okay, we're going to look back some more at probability. A probability of 1 means it will occur no matter what. Absolutely, no doubt, it will. It will occur. And probability actually does vacillate between 0, it won't occur, and 1, it will occur. And then there's all kinds of area in between there. So if you had a bag of marbles, okay, and they were all blue, the probability of drawing out a blue marble is 1 because they're all blue. So it would be however many in the bag out of however many in the bag. If there was 40 in the bag, it would be 40 over 40. If there was 10 in the bag, it would be 10 over 10. Because no matter what, if they're all blue marbles, the probability of getting a blue marble is 1. Now, the probability of 1/2 means it could occur, but then again, it might not. It's a half and half kind of thing. Most commonly, we see a probability of 1/2 is when we're flipping a coin. If you flip a coin, you get heads or tails. So 50% of the time you should get heads, and 50% of the time you should get tails. So that is a 1 out of 2 chances. If it was a decimal, it would be 0.50. If it was written with a colon, that's the two little dots, it would be 1:2. If it's written as a percent, it would be written as 50%. 50% of the time you'll get heads, 50% of the time you will get tails. A probability that is greater than 1/2 will most likely occur. It's got a better chance of occurring than not occurring. Likewise, a probability that's less than 1/2 is less likely to occur. So I'd like to see this in your notes, even though I know there's a couple other models in the book that are pretty good. I like this model because it gives you a pretty good picture of where probability falls. 0 is impossible, not going to happen. That's the getting a 7 on a 6-sided dice with numbers 1 through 6. 1 is absolutely, it will happen. That's pulling a blue marble out of a bag of blue marbles. Even chance, half and half. A good example is heads and tails. When you start moving to the left of half, it's not as likely to occur. It might be a 1 in 6 chance, or a 1 in 4, which is not very likely. But when you start getting past the middle, it's more likely to occur than to not occur. 4 in 5, 4 out of 5 times it's going to occur. 7 out of 8 times it's going to occur. You think of these as fractions, but when you're talking about probability, it's really like 1 in 6, 4 in 5, 1 in 2. And so they cease being fractions for a little while to show probability. Okay, there is a formula, and I would like you to write this down. There's a formula that we use to find probability of an event occurring. And that formula is this. The probability of an event occurring is the number of favorable outcomes over the total possible outcomes. Favorable means what you want. Okay? If you want a blue marble, then how many times can that blue marble happen? Total possible outcomes, how many marbles are in the bag? Okay? So let's say we have a bag with 10 marbles. Now you really always got to pay attention to how many marbles are in the bag total, because that's going to be your bottom number, okay? Especially when you're dealing just simple probability. So you have 10 marbles in the bag, okay? There are 6 green ones, 2 red ones, and 2 black ones. We want to find the probability of picking a specific color of marble. Now this is a really pretty easy thing to do, and once you see it, you'll go, oh yeah, I understand that. I remember doing that. Okay, so let me get the page turned here so that we can. Okay, so remember our formula is the number of favorable outcomes over the total possible outcomes. We're going to use that formula. So the chance of getting green. Remember there were 6 green. And there are 10 total marbles. So, the chance, the probability of getting green is 6, which is the total number of green in the bag, over 10, which is the total number of marbles. Okay? Now you can change this, reduce it, and then it's 3 and 5 times, or it's 0.60, or it's 60%. All of these say the same thing. 6 over 10, 3 over 5, 0.60, and 60%. How about getting a red marble? Now this is some good stuff here to write this down. I just don't want to talk about it because I don't want to spend too much extra time on this. I want to get through it. The probability of red, there were 2 red. So again, 2 out of how many? Yeah, you're right, 2 out of 10. So we got 2, the probability is 2 out of 10. Or 1 out of 5, or 0.20, or 20%. They're all the same. They all say exactly the same thing. That's the probability. Therefore, the probability of drawing red is 20%. Now, we had another color in that bag, and it was black, I believe. And there were 2 black as well. So, the probability of drawing a black, 2 out of 10. 0.20. Okay, 20%. But what is the chance of drawing an orange out of the bag? Well, if you go back to our notes here just a little bit, the colors we had in the bag were green, red, and black. Do you see orange written there? I don't see orange written there. So therefore the probability of getting orange, 0 out of 10, or 0, or 0%, because there's no orange marbles in the bag. So that's one time when you're going to have a 0%. Okay, now there's another way that we do probability, and we do spinners and dice. Sometimes we do spinners by themselves and dice by themselves. Sometimes we do spinners and dice together, and that's more compound probability, and we won't get into too much that right now. We will eventually touch on that, but not right now. Okay, a dice usually has 6 numbers on it, or dots. Okay, so to get a specific number on one roll, the probability would be, well, you don't have any repeats of numbers, so you're going to have 1 out of how many could you possibly get? Well, if it's a typical dice and there's 6 numbers, 1 through 6 on it, it would be 1 out of 6. Okay? However, what is the probability of not getting a specific number? Well, the probability of getting it is 1 out of 6. So its complement is the probability of not getting it, which is 6 minus 1, which is 5 out of 6. These are the numbers that are not wanted. Okay, say you wanted 3. These would be 1, 2, skip 3, 4, 5, 6. 1, 2, skip 3 because you don't want 3, 4, 5, 6. And this, of course, is still the total numbers. It is called the complement, and the complement in probability is the chance of not getting what you want. So definitely put that in your note. Okay? If 1/6 is the probability of rolling a 3, then the complement is not rolling a 3, and therefore it is 5/6. Okay? All right. Now, a spinner can be spun several times. We might be looking for a specific set of numbers in a specific order. So I'm saying that we're looking for 2 numbers. We're going to spin a spinner twice, and we want to have a certain number the first time and a certain number the second time. So this is how this works. Here's an example. Okay, we are going to spin this spinner twice. Okay, and we are doing, right now, we are really doing what is called theoretical probability. Theoretical probability is in a perfect world. We're not actually spinning it. We're just figuring the probability based on possible outcomes. This is theoretical probability. The other type, when you actually spin the dice or spin the wheel, throw the dice, is called experimental probability, and that's when you're actually physically doing it. Right now, what we're doing is called theoretical probability. Anyway, we're going to spin the spinner twice. We want to know the outcome. We want the outcome of 3, 2, which means we want 3 first, spin, get 3. We want 2 second. Okay? How do we compute that probability? Well, that's just a little more complicated. We get this by looking at all of the possibilities. And I made a chart right here, and it's a sample space. Put that in your notes. When you list all of the possibilities, all of them, this is called a sample space. So here's how it works. You could get 1 on the first spin and 1 on the second. You could get 1 on the first spin, 2 on the second. Still get 1 on the first spin, 3, 1, 4, 1, 5. You could get 2 on the first spin, 1 on the second, 2, 2, 2, 3, 2, 4, 2, 5. You could get 3 on the first spin, 1 on the second, 3 and 2, 3 and 3, 3 and 4, etc., etc., etc. We're only looking at one specific set right here. Okay, 3, 2. It only occurs once. So our top number is going to obviously be 1. But the bottom number is all of the possibilities. So 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5. 1 out of 25. So if we count the number of times it occurs, that's our desired outcome. When we count it, we end up with the probability is the number of times it's going to occur, theoretically, out of the total times that it could occur, which is 25. So the probability of getting 3 and then 2 is 1 out of 25 times. I hope that makes sense. It did to me. Okay, now this is the last part of the lecture, and this goes back to parts of a whole. And it is, this is pretty quick, so it won't take you too long. Problems about parts of a whole. may look like this. Okay? Part plus part equal whole. So, like I said before, half a glass plus a half a glass equals a whole glass. Okay? If 1/3 of the students in this school attended the concert, 1/3 right here, I made a nice little circle graph. If 1/3 attended the concert, what fraction did not? Well, 1/3 did. What do you have left over here? And that would be, you've got a 1/3 here, right? And you've got a 1/3 here. And that's 1/3 plus another 1/3. I'm thinking maybe 2/3. But we can work it out in kind of a nice little formula here, and it's not really hard. We're going to let B equal the students who did not attend. And then we have a part plus a part equals a whole. We're going to write ourselves a little formula right here. We're going to say 1/3 of the students did plus what part of the students didn't makes a whole. The whole circle. We want that whole circle, which would be 1/1. Now we go back and look. Well, let's see. I know that 1/3 plus 2/3 equals 1. And that would be the easy way to solve this problem. So you have 1/3 plus 2/3 equals 1. So 2/3 did not attend. And that's a basic one. Very basic to understand that. Drawing a picture, though, is always a good idea. If it were me, every time I approached a problem like this, I would draw a picture. Okay, and the last one, actually I've kind of talked about this, so it really will go pretty fast. Sometimes we deal with percents. So if something is 30% full, okay, and that's being an optimist, right? If we said it was 30% empty, that'd be a pessimist. We're going to say it's 30% full. We want to know what percent is empty. Now you can probably do this in your head, but I drew a picture. A part plus a part equals a whole, and a part plus a part equals 100% because 100% is whole. So what part plus 30% equals 100%? Sorry. So we have 30% full. What part plus 30% equals 100%? Well, I did a little bit of algebra here, and I subtracted the 30% from here. And I'm going to subtract the 30% from here to get my P. And of course, 100 minus 30 is 70%. So it is 70% empty, 30% full. Do you want to be a pessimist today or an optimist today? Okay. If you're going to be an optimist, it's 30% full. If you're going to be a pessimist, it's 70% empty. Well, I hope this wasn't too long, and I'm glad that you were able to listen today. I hope you have a great day, and we'll see you later.